Welcome to this predicted paper from onmaths. This paper represents the best guess for the upcoming exams. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions and mini mocks. If you like what we do, please consider subscribing. Enjoy! For us to create the largest number, we need to pick the biggest digits for the start of the number. So the biggest digit is 7, then 6, then 4, then 3. But the question says it wants the largest even number, so we need to just swap the last two around to make sure that it is even. So our answer is 7,634. So with this question, we need to first of all count how many sides this polygon has. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's 10 sides. And we just need to know that a 10-sided shape is a decagon. Now we are expected to know all of the names of shapes between 3 and 10 sides, so if you don't know them already, just sit down and learn them. Whenever you have this situation where you've got two lines intersecting or hitting each other, the two angles that are created either side of the line are always going to be equal, and we call these vertically opposite angles. So A is going to equal 120 degrees. You'll normally also need to write down the fact that they are vertically opposite angles. Multiples are just a numbers times table. So to write the multiples of 11, we're just going to do 1 times 11, 2 times 11, 3 times 11, 4 times 11, and 5 times 11. Now we're not going to do any more because it says it just wants the first 5. So just going to write those down in a list with commas, separating them. To answer this question, we're going to find the answers to the numerator and denominator, then we're going to divide the two. So 3 plus 42 is 45. 5 times 3 is 15. And what this line means in the fraction, it means divide. So we're going to do 45 divided by 15. So I'm just going to go through the 15 times table and just work out that's 1 times 15, 2 times 15, 3 times 15. So 3 15s in 45. Whenever we multiply two negatives, we always get a positive, so we know our answer will be positive. We're going to do 9 times 12, which is going to be 108, and v times v, which is going to be v squared. So 55% is the same as 55 over 100. And what I can do is I can divide top one of the fraction by 5. And so that is going to equal 11 over 20. Now in total there are 20 squares here because there's 5 across and 4 down. 5 times 4 is 20. And if there's 20 squares and we're looking to shade in 11 20ths, it's just going to be 11 squares. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Something to realise in this table we're given in this question is that the triangle has 3 sides, quadrilateral 4, pentagon 5, and hexagon 6. And that number is just 2 less than the number of faces. So basically, if you've got the number of sides, you add 2. So 4 plus 2 is 6, 5 plus 2 is 7, and 6 plus 2 is 8. So if we've got 20 sides, and we just do the same thing, so we're just adding 2, then we should have 22 faces. So our answer is 22. So for shop A, they're selling the rulers in lots of 3. And so we just need to get our 60 and divide it by 3 to figure out how many lots of 3 we have. So we've got 20. So if one bundle of rulers cost £1.50, then 20 times £1.50 would be £30. So in total it would cost £30 at shop A. We're going to do the same for shop B. Their bundles are 5 rulers, so we're going to do 60 divided by 5, which is 12. So we're going to buy 12 bundles at £2 each, and that will be £24. So the cheapest price is at shop B at £24. The range is the biggest number, take away the smallest number. The biggest number in this stem-leaf diagram is found at the bottom right. So this 9 here represents 69. So it would be 69, take away, and the smallest number is always at the top left. So this 4 here represents 34. So it would be 69, take away 34, which is 35. We're going to start just by copying out the question. Now when we're asked to solve, it means we need to find x. Okay, and I'm going to start by putting in my solving lines, which are just lines to the left and right of the equal sign. And what we need to do is get x on its own on the left hand side. Well, what's stopping x from being on its own? We've got this 12 here. Well, what's that 12 doing to the x? Well, it's timesing it by 12. So we need to do the opposite of that to get rid of it. What is the opposite of times 12? Divided by 12. Now these lines show us we've got to do the same to the left and right. So if I divide the left hand side by 12, I have to divide the right hand side by 12. So on the left hand side we just have the x, which is what we want. On the right hand side we do 36 divided by 12. How many 12s in 36? That would be 3. So our solution is x equals 3. Another way of thinking about 19 over 8 is just 19 divided by 8. And to do 19 divided by 8, we put 8 on the outside and we do the bus stop. And we've got 19 there. So 8 doesn't go into 1, so we're just going to move that 1 across. 8 goes into 19 twice, but there are remainders, so we'll need to put some zeros on the end here. And it's remainder 3. 8 goes into 33 times, and there's a remainder of 6. 8 goes into 67 times, and there's a remainder of 4, and 8 actually goes exactly into 40, so we didn't need some of those zeros. So the answer will be 2.375. If we write in how many sides each shape has, triangle has 3, quadrilateral 4, pentagon 5, hexagon 6, you'll notice the number of vertices is twice the amount of each of them. So if a shape has 15 sides, we just times that by 2 and it will have 30 vertices. I'm going to rewrite this expression by putting a times sign in, so 9 times x minus y squared. Then I'm going to substitute in the values, so x is 4, so it's going to be 9 times 4 minus, and then y is 3, so it's going to be 3 squared. So 9 times 4 is 36, 3 squared is 3 times 3, which is 9. And 36 take away 9 is going to be 27. So the first thing we're going to do is write this as a ratio between the fractions. So we're going to have green to black. Now it says that a quarter of the counters are black, and therefore the remaining counters will be green. So if a quarter are black, that leaves 3/4 to be green. And what we can do here is on both sides of the ratio, what I'm going to do is just times it by 4. So I'm just going to times 4 both sides. So 3 divided by 4 times 4, because over 4 just means divided by 4. So 3 divided by 4 times by 4 just gets rid of the fraction. And 1 divided by 4 times 4 is just going to be 1. Now this might surprise some people because they will probably think it's a ratio of 4 to 1. But we can show here that it's a ratio of 3 to 1. So to do this question, you just need a piece of paper, a ruler and a protractor. And the first thing we do is we draw the 11 centimeter line. And my one will not be 11 centimeters for you. It is on my screen, but because depending on what device you watch this on will change obviously its length. And what I'm going to do is I'm going to put my protractor on this end here. So I've kind of got my protractor here. And I'm going to just have a look at getting 39 degrees. Now you've got to be careful because 39 is on the inside, and I'm just going to do a dot. So always look to see which one, the inside or the outside of the protractor, starts at 0, and the inside should start at 0 from this side. And I'm just going to draw a line that connects the end of that line and the dot. Like so. Now just you can keep it going. Right, the next thing I'm going to do is put my protractor on the other side. So my protractor is kind of here. And I'm lining up the crosshairs with this point here. But this time I'm measuring on the left hand side. And I'm looking at 59 degrees, which will be here. Get my ruler. Now this time I can actually stop where it hits the other line. So keep going and then stop where it hits the other line. This screen's not perfectly calibrated, so it's difficult to do precise work, something like that. And then what you can do is you can get your rubber and just rub out the extra bit of line that we had to do. And so this is our 39 degrees here. And you don't need to label this on the diagram, but just so we know what we're doing. And it says when it's completed, measure length x. So I'm going to get my ruler out and I'm going to measure this length here, this one here, and it is about 95 millimeters. So the answer for me is 95 millimeters. Now there is some level of precision. You're not going to get necessarily exactly 95 millimeters. When we mark these questions, we normally have an overlay and we put it over the top, and if it's roughly the same, and you can make small errors because nobody's perfect, and my diagram definitely is not perfect, but there are allowable small errors here and there. So the pass mark for the test is here, and we can see that there are 2 students who passed the test. So it's 2 students out of 2, 3, 4, 5, 6, 7 in total, and we want this as a percentage, so we're going to times it by 100%. So we do 2 over 7 times 100, and that gives us 28.571 blah blah blah, and it says it wants it to the nearest percent, so that will be 29%. To get from the length of a square to the area, we square the length. To work backwards, what we do is we square root, because the inverse of square is square root. So we've got 196, and we're going to square root it to find the length. So we work out the square root of 196, which is what number times itself is 196. And you should learn them from 1 to 15, so you should know all of the square numbers from 1 to 15. So you should know that the answer is 14. So the length therefore is 14. So to work out what the perimeter is going to be the distance around the square. So if I draw a square out, we know that each of these lengths are 14. So it's just going to be 14 times 4, which will be 56. So we've got to first of all make these both the same units, because at the moment they are different units, and when we have ratios we always want to make sure that they have the same units, and then we can get rid of the units. So I'm just going to make them both into grams. I'm going to do that by timesing the right by 1,000. And the reason I've chosen grams rather than kilograms is you want to always pick the smaller unit. Otherwise you'd be left with a decimal on the left hand side, you'd be 0.2, and that can be a bit more complicated. Okay, so I'm going to remove the units now, and we're just going to focus on the numbers. So we can divide both sides by 100. straight off the bat. So we've got 2 to 40. We can see we can divide them both by 2. And so we've got 1 to 20. And so it's 1 gram to 20 grams, or just 1 to 20. So with a stem and leaf diagram, the numbers in the middle often represent tens. They could be units. So we look at the key first of all, and we see that 3 line 9 means 93. So the numbers in the middle are going to represent 10. So this is a 90. Now we're looking for English, so this will be 92. So our first number will be 92. Then this will be 10 tens and a 4, so it would be 104. 11 tens and 1, so 111, and then 11 tens and 2. So to find the median, we go cross out the biggest and smallest until we're left with 1 or 2 in the middle. Here we're left with 2. So what we're going to do is we're just going to add the 104 to the 111, and we're just going to divide that by 2. So when we do that, we get 107.5, or 0.5. So our answer is 107.5. To find the surface area of the cuboid, I'm just going to label the faces and do them individually. So we've got A, which is 24 by 13. So we're going to do 24 times 13, which is 312. Next we're going to do B, which is this one at the top, and it's 24 across and 8 is the length. So 24 times 8, which is 192. And finally C on this side here, which is going to be 13 times 8, which is 104. Now notice that the faces all have the exact same face on the opposite side. So this one at the back is also A, this one at the side is also C, and the one at the bottom is also B. So what I'm going to do is add up all the areas of the squares and double it. So to work out the surface area, we're going to do 2 times and then 312 plus 192 plus 104. And that will give me 1,216 centimeters cubed squared, because it's an area. The median is the middle number when the numbers are in order. Now it's quite difficult to do with a table, so we used a formula, and that formula is to find the position of the median. We do how many numbers there are, which I'll call n. We add 1 to it, and then we divide that by 2, and that shows us where the median is. It doesn't tell us what the median is, it shows us where it is. Now we need to figure out where these numbers are in this list. So the first number is a 2, and there is 1 of those. The next number is a 3, and there's 3 of those, so 1, 2, 3. The next number is a 4, and there's 4 of those, so 1, 2, 3, 4. The next numbers are 5, and there's 8 of those. So 1, 2, 3, 4, 5, 6, 7, 8. And the next numbers are 6, and there's 13 of those. Now I'm not going to do all of them, okay, because we're not going to be working out the median by writing out all the numbers, but I do want to show you where these numbers are coming from. So what we do is we do a running total. So I'm going to do a running total. The running total is just adding up the frequencies as we go. So the first one is just 1. Then we're going to add the 3 in the next row, so that's 4. Add the 4 in the next row, 8. Add the 8 in the next row, 16. Add the 13 in the next row, and that would be 29. Now we use the running total because the running total shows us where the last number is in that group. Okay? So this shows us that the first number is the last number that is a 2, which is true, we can see it here. This 4 shows us that the fourth number is the last number that's a 3, so let's check that. 1, 2, 3, 4, it works. This 8 shows us the 8th number is the last number that's a 4, let's check that. So 4, 5, 6, 7, 8. This 16 shows us the 16th number is the last number that's a 5. So 9, 10, 11, 12, 13, 14, 15, 16. And this 29 here shows us that the 29th number is just the last number, but it's the last number that's a 6th. Okay, so let's work out how many numbers there are, and we do that by adding up the frequency. So we're just going to add up all of the frequency together, and we find out that there's 29 numbers altogether. So 1 plus 3 plus 4 plus 8 plus 13. So using our formula, which is 29 plus 1 divided by 2. 29 plus 1 is 30, divided by 2 is 15. So we're looking for the 15th number. So looking down our running total list, well, the last number that's a 4 is the 8th number, so we haven't got to the 15th number yet. And the last number that's a 5 is the 16th number. So if the last number that's a 5 is the 16th number, then surely the 15th must also be a 5. And so our median is 5. These types of angles aren't exclusive to parallel lines, but they do crop up quite a lot of times when you're dealing with parallel lines. And these are vertically opposite. So when you've got an angle this side and an angle this side of where two lines intersect, they're known to be vertically opposite. And the beautiful thing about vertically opposite angles is they are equal. So x is just going to equal 15 degrees. And the reason you need to state is that they are vertically opposite. Make sure you state vertically opposite. Sometimes in some exams opposite is enough, and in other exams it has to be vertically opposite. Here we're given two angles on parallel lines, and the parallel lines are here and here. And if we draw the line that they are on, then it creates a little C shape. Now, whenever we were dealing with C angles, we call them either interior, co-interior, or allied angles. And what we know about interior angles, I'm just going to call them, is that they add up to 180. So we can get that 20x, and we can add to the 40x, and we know that that equals 180 degrees. And I need to make sure I write down the reason, because they're interior angles. So here I'm going to be solving this algebra. I'm just getting my tramlines in. 20x plus 40x is 60x, equals 180. And we're going to divide both sides by 60 to get x on its own. So we can solve it. And we've got x equals 3. So the value of x will be 3. So I think about ratios as piles of money sometimes. And here we've got J getting 5 piles of money and Anne getting 4 piles of money. And each pile is going to be equal. So we've got to first of all work out how many piles of money there are. So we just add the 5 and the 4. So there's 9 piles of money. We sometimes in maths call them parts. So we say that we have 9 parts, okay, or 9 piles of money. Now, each part, oh, I've got an equals there. Each part or each pile is going to be worth what 99, okay, which is the total amount of money, divided by how many equal piles we have. So divided by that 9. So 99 divided by 9 is 11. So one part is worth £11. So J has 5 piles of £11. So J has 5 times 11, which is 55. And Anne has 4 piles of that money. So 4 times 11, which is 44. We can check this by adding the two together. And it should add up to the amount of money we have, which is 99, which it does. So if we imagine we've got the 25 metre pipe here. And we've got the 35 metre pipe here. The question's basically asking us what can we cut all these pipes into, and they all have to be the same length that will fit with the 25 metre and the 35 metre. And essentially what this question's asking is what is the highest common factor of 25 and 35. So to find the highest common factor, what we do is we just find the factors of 25, which is 1 and 25 and 5 and 5, and the factors of 35, which will be 1 and 35 and 5 and 7. And the highest common factor is the number in both lists, the highest number in both lists, so it's 5. So what we can do is we can cut all of these pipes into 5-meter pipes. So 1, 2, 3, 4, not to scale, and then 7 of these. So 1, 2, 4, 5, 6, and so there's 7 in total. So each of these are 5-meter long, and there's no wastage. And that's the longest we can make the pipes for there to be no wastage at all. So my answer is 5 meters. So we're going to start by understanding that all lines form or can form an equation y equals mx plus c, with m being the gradient and c being the y-intercept. It says here the gradient is -2, so we've already got a bit of a head start with this, but we don't know what the y-intercept is. So we're going to use this first set of coordinates to work out what the y-intercept is. So y is -31 and x is 15. And we're going to use this to solve and find out what c is. So first thing I'm going to do is, well, just tidy this up. 2 times 15 is 30, so -30 plus c. And I'm just going to add 30 to both sides to get c on its own. So that would be -1 equals c. So c is -1. So we now know that the equation is y equals -2x minus 1. And we're told that the y is -37. And we're looking for the x value, which they've called w. So let's get our solving lines in. Okay, so the first thing I'm going to do is add 1 to both sides. And so it would be -36 equals -2x. I'm going to now times, or divide everything by -2. And a negative divided by a negative is positive. 36 divided by 2 is 18. And then obviously that gets rid of the coefficient of the x, so it's just x. So x equals 18, so the x value is 18 and the x value is the w value. So w is 18. To find the pressure, we need the area and the force. And we're given the force in the question, and so all we need to do is find out what the area is, which will be the 7 times the 9, which will be 63 centimeters squared. And the force is given to us in the question, so what we can do is write down the pressure formula, which says that pressure equals the force divided by the area. Force is given to us as 2268. The area we've calculated is 63. Divide the 2 and you get 36. So it's going to be 36 newtons per centimetre squared. So in this question we are told that the centre of enlargement is at 6, 4. So let's just put across that. And what I'm going to do is just draw ray lines from the centre of enlargement, and we're just going to go through each of the corners of our shape A. And we're going to just check whether it goes through the corner of shape B, which it does on this one. Let's just keep going. Yeah, it does on this one. But it does not on this one. So it says find the coordinate of the vertex of shape B that is not correct. So the coordinate is this one here. And so that would be -4, 1. So the symbol here basically means and the way I remember it is if you draw that symbol and just put a line through it, you can make the word and. So we're looking at the probability of getting something that is in A and C. So the only ones that are in A and C are this 8 and this 9 here. So we're going to just add the 8 and the 9 together, which give us 17. Now we need to then work out how many numbers there are in total, so that's all of them. So 4 plus 8 plus 9 plus 5 plus 8 plus 3 plus 11 plus 6. So we need the total, which is 54. And then we get the 17, and we put that over the amount in total, so over 54. So this question is asking us really to divide the 5 3/4 by 1 3/4. So we're going to do 5 3/4 divided by 1 3/4, because we're finding out how many of each of these towels, which is 1 3/4 meter, can be made when the total amount of cotton is 5 3/4. So first thing we're going to do is convert them to mixed numbers, to top-heavy or improper fractions, because at the moment they're mixed numbers and we can't divide or times if they're mixed. So we times the 5 by the 4 and add it to the top, which will be 20, and then add it to the top 23, and then do the same. 1 times 4 is 4, plus it to the top is 7 over 4. Now a little trick here is KFC. We keep the first fraction, we flip the second fraction, and we change the divide sign to a time sign. So we're going to keep this first fraction as it is, change that divide to a times, and flip the second fraction. Okay, whenever we multiply, we just multiply the tops, so 23 times 4, which is 92, and we times the bottoms, which will be 28. And now we need to convert this back into a mixed number. So first of all, actually we can simplify this, because we can divide top and bottom by 4, so that would be 23 over 7, and then make this a mixed number. So 7's into 23 go 3 whole ones, and then obviously 2 remainders, so it's 2 over 7. Now it asks us for the amount of towels that she can sew patterns into. Now the issue here is that she will do 3 whole towels, but then have some left over, but she doesn't have enough to create a 4th towel, so it's just going to be 3 as an answer. So for this question, what we need to do is factorise 4t plus 6. Now factorise means put it into brackets. So if I try, what I can do is I can actually put a 1 on the outside here. So 1 times 4t plus 6 is 4t plus 6, but the question clearly states that it is higher than 1. So we need to find another number that's higher than 1 to factorise this with. So if we look at 4t and 6, well, they're both in the 2 times table. So I can put a 2 on the outside here. 2 times 2t is 4t, and 2 times 3 is 6. So what we can do is we can just check that out with smiles and rainbows. Put all my times down there to remind me to times it. So 2 times 2t is 4t, 2 times 3 is 6. So that works because that is the same as this in the question. So we know that 2 times 2t plus 3 works. In fact, it's the only one that works with it being an integer. So we therefore know that the known side, because it says it's a known number, is 2, and the other side will be 2t plus 3. And then when you multiply them together, you get the area of 4t plus 6. So our answer, because it says the length is the known number, so that's the length, then we're finding the width, which is this one here. So it's 2t plus 3. Sometimes it's easier with these questions to multiply both numbers by, say, 10 or 100 or 1,000. So if we look at the 0.06, if we times that by 100, it would make the question a lot easier. But with a division, if you times one of the numbers by 100, you have to times the other one by 100. So we just go times the 30 by 100, and times the 0.06 by 100 to make that 0.6. And this actually is the same calculation as 30 divided by 0.06. The reason being is that you can write that as a fraction. And you know with fractions, you can just times the top by something and times the bottom by something. It doesn't change the fraction at all. It just keeps it exactly the same. So we're going to use the bus stop method to find out what that is. So we're going to divide that out. 6 doesn't go into 3, so carry that. 6 is into 30, go 5, 6 into 0, 6 into 0. So that's going to be 500. So it's really important, first of all, we make clear about how we convert things. So if I've got a unit in kilometers and I want to convert it into meters, then we know we just times it by 1,000. So 2 kilometers is 2,000 meters. But if I have something in kilometers squared and I want to convert it into meters squared, I actually times it by 1,000 squared, which is 1,000 times 1,000. Okay, so I'm actually timesing it by not 1,000, but 1,000 squared. So that's another 3 zeros. You can see here that that's 1,000,000. So we times it by 1,000,000. So 13 kilometers squared is going to be the 13, and then it's going to be times by 1,000,000. So 1, 2, 3, 1, 2, 3. So it's going to be 13 million. Now, it says here the farmer must pay 1 pence tax for every metre squared. So this is going to be 13 million metres squared. And so that's going to cost him or her 13 million pence. But the answer is going to be in pounds. So we just need to get rid of 2 of the zeros at the end. So it's going to be 13, 1, 2, 3, 4. So it's going to be £130,000. To rearrange this, I'm just going to write out the equation again. And I'm going to put my lines in. Okay, so the first thing I'm going to do is try and make the x positive, because we're looking to make x the subject of the formula, which means we need it to be x equals. So what I'm going to do is just add x both sides. So we've got x plus m equals 10. Then we want to get rid of anything on the left hand side that's not this x. So we want to get rid of this plus m. So we're going to do that by subtracting m both sides. So we've got x equals 10 minus m. So our answer is 10 minus m. X equals 10 minus m. Factorising is the opposite of expanding. With expanding, we're multiplying out a bracket. With factorising, we're putting something in a bracket. So I'm going to start by just putting the bracket down. Now I need to ask myself, what number can I divide out of 3x squared and 5x? Well, there's not going to be a number I can divide out, but they both have at least an x. X squared obviously is x times x, and x is just on its own for the 5x. So we're going to divide out the x. So I need to ask myself, what times x is going to be 3x squared? Well, obviously 3x. And then we ask ourselves, what times x is 5x? Well, that's just going to be 5. And if you were to expand that set of brackets, you will get 3x squared plus 5x. So we know it's the correct one. And so our answer will be x brackets 3x plus 5. So we're going to start off with x equals 0. And we're going to write out this equation, but with 0 every time it says x. So it's going to be y equals 0 squared minus 0 plus 10. Well, 0 squared is just 0, so 0 take away 0 is just 0, plus 10 is just going to be 10. So the answer there would be 10. Could do the same for 1. So it would be 1 squared minus 1 plus 10. Well, 1 squared is 1, 1 take away 1 is 0, plus 10 is 10. So that will also be 10. 2 squared minus 2 plus 10. 2 squared is 4, 4 take away 2 is 2, plus 10 will be 12. Now we're going to do the negative, so we're going to look at minus 1. So it's y equals minus 1 squared, and it's going to be minus 1 plus 10. So a little bit more complicated here. Minus 1 squared is just 1. Now here you have two negatives together. When you have two negatives together, it makes a plus. So we've got 1 plus 1 plus 10, which is going to be 12. And then we'll do the minus 2, so it'd be minus 2 squared minus 2 plus 10. So minus 2 squared is 4. The two minuses here make a plus, so it'd be plus 2, which would be 6, plus 10 will be 16. So we're going to plot these on our graph. And so we've got minus 2 is at 16, so that'll be there. Minus 1 is at 12. Be here. 0 is at 10, 1 is at 10, and 2 is at 12. Okay, when you join this up, things to be aware of is you need to make sure that you have a round U at the bottom and not a flat bottom. Okay, so you want to avoid a flat bottom. You also want to make sure that you avoid feathering like that. You want just one nice smooth line. And my recommendation is always to turn the page on its side. I don't have that luxury, so I'm going to try my best with this. But you need to make sure it goes through all the points. And here's the part here where it goes beneath those 2 points. So make sure it goes beneath those 2 points. On most exams, I see them, basically what they do is they draw a line across from those 2 points and say that the line needs to go beneath that, or your curve needs to go beneath that line. So they're looking out so that you've gone beneath the line. So I'm going to write out the equation again just to give us a bit more space. And the rule we have here is if we have an x on both sides, which we do in here, we pick the smallest one to get rid of. So we've got a 12x and a 7x, and so the smaller number, or the smaller x, would be the 7x. So we're going to get rid of that first. So we've got our lines in, and we're going to take away 7x both sides. And so 12x take away 7x is 5x, and the 7x is gone, so it's just equals to 46. Then we've got the minus 4 to get rid of, so we're going to add 4 both sides. And then we've got this times 5 here, so we're going to divide 5 both sides. So we've got x equals 50 divided by 5, which is 10. I'm just going to write the question out a bit bigger, just so we've got more room. And loads of different methods of expanding brackets. I'm going to do smiles and rainbows. So we just draw a smile rainbow, and I'll put a little line there to remind me to times it. So we do 5 times 7, which is 35, and it's 7x, so it's going to be 35x, and 5 times 4, which is 20. So our answer is 35x plus 20. So this question is a simultaneous equations question, and so we're going to have to write down some equations. So it says 2 apples and 3 pears cost £3.80. So 2 apples, I'm going to call it A for the price of an apple, plus 3 pears, so 3p, cost £3.80. Now I'm going to do this as 380 just because it's easier to work with integers rather than decimals. And it says 3 apples, so 3a, plus 8 pears costs £7.80, or 780 pence. Okay, so the first thing I do is try and get these numbers the same. So 3 and 8, they both go into 24, so I need to make them both 24. And what some people do is they just label this A and this B. And so what we're going to do here is we're going to multiply everything in equation A by 8, so that this becomes 24. So it's going to become 8a. And so we're going to times the 2a by 8, which will be 16a, plus 24p, and 380 times 8 is 3040. And we're going to do the same with b, but this time we're going to times it by 3, so we're going to have 3b. And we're just going through everything here and we're timesing it by 3. So 9a plus 24p, which is good, that's what we wanted. And 780 times 3 is 2340. So now we've got both of these the same coefficient. What we can do is we can eliminate going downwards. Now, if they are the same, the s in same is the s in subtract. If they were different signs, so if these weren't both positive, if one of them was negative, different, the d in different is the d in add. So here they are the same, so we are going to subtract, and we're going to subtract going downwards. So we're going to start off by doing, and I can just do a little line here to show what we're doing. So we're subtracting going downwards, and we're going to do 16a take away 9a, which will be 7a. 24p take away 24p, which is nothing, which is why we did that, is to eliminate them. And then 3040 take away 2340, will be 700. Then I can put my lines in, and all I need to do now is just divide both sides by 7, and I get A equals 100. So we know that apples cost 100, or £1. We need to work out what pears cost. So I just need to pick one of the equations. I'm just going to pick this top one here, and I'm going to write it out. But instead of A, we know that A is £1 or 100 pence. So plus 3p equals 380. So that's going to be 200 plus 3p is 380. And then again, I'm just going to draw my lines down. And we're going to subtract 200 from both sides. So it's going to be 3p equals 180. And then we're going to just divide by 3 both sides. And we've got p equals 60. So a pear costs 60. Now we can check this by using the other equation there. So 3 times 100 is 300, plus 8 lots of 60 is going to be, what's that, 480? So it's going to be 780. So we know that we've got it right. When it's said that y is inversely proportional to x, it means that y changes as 1 over x changes. And to write this in an equation, all we do is we just write y equals k over x. Now k is something we need to find. So what we need to do is find out what a value of y and a value of x are somewhere on the graph that would be formed from this, and we've got that in this question. So we know that when y is 7, then x is going to be 7.9. And what I need to do now is just draw my lines down. And what I'm going to do is I'm going to just times both sides by 7.9. And so we have k equals, and it'd be 7 times 7.9, which is 55.3. So we know that k is 55.3. So I'm just going to rewrite this equation here, or this formula here. But instead of k, I know that it's going to be 55.3. So our answer is y equals 55.3 over x. So we've got to first of all understand what standard form is, and standard form is a number that is between 1 and 10, but not including 10, times 10 to the power of another number. So to find out what the numbers are going to be for our standard form, we're going to just write down the decimal first, so 0.098, and we've got to put a decimal point in somewhere to make this a number between 1 and 10. So if I put it in here, that would make it 9.8, and we're ignoring the zeros to the left-hand side. So we know that our standard form is going to start off with 9.8 times 10 to the power of something. Now this times 10 is always going to be there. It's never divided by 10 or anything like that. It's always times 10. Next, we've got to find out what the power is going to be. So first of all, if it's a small number, if it's a number less than 1, which this is, it's a small number, it's going to be a negative power. And the next thing we do is work out how many jumps we had to do. So it would be 1, 2 jumps between where the decimal point was and where it is now. So 2 jumps means it's going to be to the power of -2. So we can write this as a fraction. So it would be 2.84 times 10 to the power of 11 over 4 times 10 to the power of -2. What we can do is split this up into 2 fractions. So 2.84 over 4 times 10 to the power 11 over 10 to the power of 2, or -2. Okay, so we're going to start by doing 2.84 divided by 4. So we're going to just do the bus stop method. So 4 on the outside, and we've got 2.84 on the inside. 4's into 2 don't go, so carry the 2 across. 4's into 28 go 7, and 4's into 4 go 1. So it's going to be 0.71 times, and then the rules of indices say that if you divide two powers of the same base, they're both 10, then you just take away the power. So it's 11 take away minus 2. Now the two minuses, the two takeaways, actually convert to a plus, so it would be 11 plus 2, which would be 13, so it would be 10 to the power of 13. Now we've got a bit of a problem here, because standard form must have a number between 1 and 10, and not including 10, at this position here, and this is obviously less than 1, so we need to convert this into standard form. So what we can do is just write the number out again. So I'm going to write this as an actual number, so it's 10 to the power of 13, so it would be 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13. Fill in the zeros. So it would be 7, 1 and all those zeros. And then I'm going to put it back into standard form. Now the decimal point will need to be here to make it 7.1. So it would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's going to be 7.1 times 10 to the power of 12. Now, with a bit of practice, you don't need to write out the whole number. You'll be able to just know that if you convert that into 7.1, then you just need to take away 1 from the power. But if you're not sure, and it's not an unreasonable number like 10 to the power of 105, then it's just worth sometimes just writing out the actual number and being 100% sure that you've got it the right way around. Acceleration is change in velocity over change in time. So change in velocity, where it starts at 0 and goes up to 150, so that would be 150, over the change in times. Well, the time starts at 0 and goes up to 5, so that's 5. And so 150 divided by 5 is 30. The velocity is in meters per second, the time is in seconds, so the units will be meters per second squared. So it's 30 meters per second squared. To find an error interval, what we need to do is find the smallest and largest that a number can be. So I start by just drawing a quick number line, and we put our number in the middle, which is 89.6. Now we're looking to the nearest tenth, so what I'm going to do is I'm going to write down the next number down and the next number up in tenths. So the next number down would be 89.5, the next number up would be 89.7. Now the bounds, the upper and lower bound, the maximum and minimum number it could be before rounding, are going to be at the halfway points. So here and here. And so all we need to do is work out what those numbers are. So halfway between 89.5 and 89.6 is 89.55. And halfway between 89.6 and 89.7 is 89.65. So those are going to be our lower and upper bounds. But how do we show it as an error interval? Well, we put t in the middle because it tells us that t is representing the time, and we show it with inequalities. Now, the number can be 89.55, but it can't be 89.65 because that would round to 89.7. So we say everything that's less than but not equal to. So to answer this question, you need to just know the answer off by heart. There is a diagram that can help us actually get there. And if we just draw a right angle triangle and put the lengths as 1, got right angle here, we can use Pythagoras, a squared plus b squared equals c squared, to work out the fact that this is going to be root 2. Because it's an isosceles triangle, this angle here is going to be 45 degrees, and same with the bottom right one, but we're not interested in that. When we label it with our marked angle here, we've got the adjacent is here and the hypotenuse is here. Now we know from trigonometry that cos x equals a over h. The angle is going to be cos 45, and a is going to be 1, and h is going to be root 2. Now, this is a bit of a strange one with 1 over root 2, because we need to actually be able to rationalise the denominator. And basically what that means, if you haven't done surds yet, or you aren't doing surds, is you times top 1 by root 2. And so we end up with root 2 over 2. So if you ever see 1 over root 2 is absolutely fine as an answer, but if you ever see the answer as root 2 over 2, the two are actually exactly the same. So writing 1 over root 2 is fine, or writing root 2 over 2 is also correct. There are two parts to this power. We've got the negative there, which means we're going to find the reciprocal of the fraction. And then we've got that 3 there, which just means we're going to find that as the power. So we're going to first of all flip the fraction. So that's going to become 3 over 5. And we've still got the power 3 there. And then we're going to cube top and bottom. So cubing the 3 gives us 27. Cubing the 5 gives us 125. So our answer will be 27 over 125. So we're asked to express TQ in terms of P and Q. Well, we've got another Q here, because all of these are congruent parallelograms. And we have a P there. So if we're starting at T and getting to Q, we can go along this path here and down this path here. So we're going backwards down Q, in fact backwards down 2 lots of Q, and then the correct way down P. So it's either minus 2Q plus P or P minus 2Q. You can complete a unique version of this paper by going to our onmaths site. onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions and mini mocks. If you like what we do, please consider subscribing.